So in number 4 for the famous potato problem, what made it difficult for kids was the way the variables were dealt with. So we're going to try to um, tackle that. So it says at time t equals 0, a potato is taken out of a pot and left to cool in the kitchen. The internal temperature of the potato is 91 degrees. That's the temperature at time 0. So make sure you understand that that's at time 0, the temperature is 91. And the internal temperature of the potato, what does it say, is greater than 27 degrees all the time. The temperature of the potato at time t minutes can be modeled by the function h that satisfies this equation. This is where you have to be really careful because h is the temperature. So really, if you were to change this just momentarily to dy dx, this is actually negative 1/4 of y minus 27. It's not the independent variable, it's the dependent variable. You're not used to that. You're used to them being functions of the other variables. So you have to be really, really careful what you're plugging in, and also when we take derivatives, what happens. So remember, just kind of keep in mind, this is actually the output that's determining the function value, where usually it's the input. It's different. So when this is t, this is h. And this actually goes in. You're used to putting this first coordinate into the function. So this is actually a function of the second variable. So be very careful with that. It affects the answers to the first two. So it says write an equation for a tangent line to the graph of h. It means I need a point on h, which I have. At time 0, I have the point 91. And I'm going to see how many points this first part is worth. It's worth 3 of them. So first thing, after we get a point, we need the slope. This is the slope. So we need dh dt when, and it's actually a function of h. So you have to be careful. When we did these in class for BC, some of the kids were putting a 0 in for h last week because that's what you're used to. You're used to plugging this x value in, but this one's a function of the temperature of the potato, so not a function of time. So what we would do is this is actually when h equals 91. And again, you're used to writing when x equals and grabbing that first coordinate. That's what really messed a lot of kids up on this one. So I would suggest just all the time when you're given non-dy dx's, if I were you, I'd temporarily replace them so you can get a grasp on what the variables are, whether they're the dependent or the independent variable. So this would be negative 1/4 of 91 minus 27. Because that's numerically accurate, that would actually get you full credit for, it's the same as what would go in on a calculator. So that's actually full credit for the slope point, which was one of the points. But since we're going to write the equation of the tangent line, I think we should probably clean that up. 91 minus 27 is 64. Negative 1/4 of 67 is negative 16. So I've got my slope of the tangent line. That would have been 1 point. And so my equation for the tangent line would be y minus the y I know is equal to the slope there times x minus the x I know, which is the t value. So I actually get y is equal to negative 16t plus 91. You'd get full credit if you left the y there. They just call that spelling errors. But this is actually to give you the temperature of the potato, so I'd write h equals. If you do that on your calculator, we're supposed to estimate the temperature at t equals 3. So we just put a 3 in. And remember, the national average on this one for AB was 1.4. For BC, it was in the low 3. So it was low scoring. And again, it was because people switched up which variable was which. Otherwise, it's quite a straightforward question for part A. When you put a 3 in, you would get a negative 48 plus 91. Remember, you're allowed to leave that because it's numerically equivalent to what it's supposed to be. So I'm just going to leave that there. The next is to find the second derivative. And again, you got to really watch those variables. So when I take the second derivative, I take the derivative of my first derivative. So when I write the first derivative down, I am taking its derivative with respect to t. So you got to be really careful again. It's kind of like if it was dy dx. There's no variable match here. So again, I'm going to repeat. If I did the derivative with respect to x of x squared, you say it's 2x. When I do the derivative with respect to x of y squared, there's not a variable match, it's a chain rule. It's a 2y, y prime. So I have to be really careful on this, that I notice that this is kind of as if this were the y and it was dy dx. And so when I take this derivative, I actually think I think I'll distribute this in just to clean it up, but I'll be doing the derivative. I know I'm writing all over the text of the next part, but I don't have much workspace here, plus some constant. I don't really care about that for now. So when I do the second derivative of that, I get negative 1/4, but it would then be dh dt, because again, it's the scenario of being the derivative of the other variable. So be very careful with that. The constant, whatever it would have been, would go to 0. So this is just negative 1/4 times, and then dh dt was negative 1/4 of h minus 27. So you can see why kids goofed that up. It was it's the variable issue. So be really careful. It's like if your first derivative was 3y plus 1. When you do your second derivative with respect to x of your first derivative, right? So this wouldn't be 3. It'd be 3 dy dx. So you're used to this happening in the FRQs. So they're messing with the variables on you for this potato problem, and it really messed with kids' heads. So what was the question? It said, so use the second derivative to determine whether your answer is an over or an underestimate. You'll notice right here, these two negative of force make a positive. So I actually have a positive fourth, which means this is greater than 0 for all h greater than 27, right? Because this is positive, and as long as this is positive, but that's why in the stem of the problem, it said that the temperature of the potato was always greater than 27. So I know my second derivative is greater than 0. What that means is my function was concave up. Therefore, my tangent line provided an underestimate. So that was a lot of work actually to get 1 point. On the scoring rubric, that was actually just 1 point for answer with reason. So, but if you did the second derivative wrong, you'd lose that point. Not a big part of it. The next part was worth 5 points. So it says for t less than 10, an alternate model for the internal temperature of the potato is given as a function of g. So let's write that down. It's negative g minus 27 to the 2/3 power. And it says based on this model, here's my initial condition, hello to find Carl, right? What is the internal temperature at time t equals 3? So we need to solve this for g. G is the internal temperature. So it says it right here. This is solving a differential equation. This is separation of variables, but it just plays out a little differently than what you're used to. So when we separate, again, we need to get all things with that top variable, the dependent variable on the left-hand side. So I would divide by g minus 27 to the 2/3. So I do 1 over g minus 27 to the 2/3 dg is equal to, I'd leave the negative on the right. I always leave any constants over because, again, our goal is to solve for g. So if I move the negative over onto the left-hand side with g, I'm eventually going to have to get rid of it anyway. So I get a negative dt. Once we separate, we integrate. So I'll integrate 1 over g minus 27 to the 2/3 dg. And I'm going to integrate negative dt. That bugged some kids this year too. I remember them coming back from the test saying there wasn't anything over there. Well, there is. It's a negative 1, and the antiderivative of negative 1 is just negative t. So that's where I think some kids bailed on it, at least my kids. Over here, this is not natural log, so beware of that. This isn't u prime over u. This is actually g minus 27 to the negative 2/3. And if my u was g minus 27, my du dg is just 1, or just dg. So this is actually u to the negative 2/3, or g minus 27 we add 1 to the power, making it 1/3, and then we divide by that. We add Carl, but Carl always gets added to the right-hand side, so you don't need to show it separately. Maybe now would be a good time to go find the C. So let's go back to the initial condition, which I forgot. When you plug in a 0 for T, you're supposed to get 91 out for the internal temperature. So I'm going to indent. I get a 91 out. Remember, G is the temperature at time T. So when T is 0, this would be C. It looks like 91 minus 27 would be 64. Cubed root of 64 is 4. So it looks like this is going to be a 12 over here. Hopefully my arithmetic's solid. I think we're good. So that's a 12. I'm going to outdent and rewrite. So I was at 3 times G minus 27, kind of a long one here, is equal to negative T plus 12. I'm going to keep solving this. I would probably, at this point, divide by 3. And then I would cube both sides. If you don't mind, I'm just going to start getting a little sloppy here. And then I'll add that 27 over. It's a very odd solution to the differential equation. We haven't had any. I'm going to make that 12 minus t just to make it prettier. That played out quite like this, but it's done. That's my solution. And then I have to go back to the stem of the problem. I think I was supposed to predict the temperature of the potato. Based on this model, what is? So I need to find G when I put a 3 in for T. So let's go do that. I would have G is equal to 12 minus 3 over 3 quantity cubed plus 27. G is equal to 9 over 3 is 3. It looks like 27 plus 27. The internal temperature of the potato is 54 degrees. The scoring rubric for where the points actually fall out for this you can find online, but I know it was 3 points for part A, 1 point for part B, so there's 5 down here for part C. So my guess is it's always 1 just for separating correctly. My guess is there was 1 point for the antiderivative, and it was probably for the one on the left because the antiderivative of 1 probably wasn't point worthy. Then there's usually a point for student includes constant. Also, student uses initial condition. There's also going to be a point either for the answer or for the particular solution. You'll have to go read the scoring guidelines. I don't know. So that one's done. But the key to this one in part A was not goofing up your variables. And I'm going to repeat that. Suppose on your test you get something like D, I don't know, Q dt is equal to 1/5 of Q. If you're asked for the second derivative, it's not 1/5 because remember we're taking the derivative with respect to t. So when I do the derivative with respect to t, I actually get 1/5 dq dt, which was actually 1/5 q. So there's some work to do when your variables don't match. Anyway, we're done.